Okay. Sectors and segments. Obviously, you need to know your formulas. You pick one. Obviously, L equals to R theta or theta R if your angles is in radians. Circumference equals 2 pi r, theta on 360, you can use that one as well. You got to remember your theta is in degrees. Cool. It doesn't matter which one you use. I think the easier one for just a safe zone would be obviously the one that I've circled. If you've memorized it, because it seems like most of you are. Me, if I ever do not need this one, I just go back to my basic formula, but whatever. So these are easy. What is the radius? Easy. All right, area of a sector is half r squared theta. That's area of a sector. Okay, again, if you didn't want to memorize that and you think or you might forget or whatever it is, you can obviously always use pi r squared, theta on 360. But please remember that theta is in degrees. Whereas this one, your theta is in radians. So in terms of pi, this is in terms of degrees, 30 degrees, 40 degrees, whatever. All right, let's do this question. That's a HSC question, but very simple. In a diagram, AB is an arc of a circle with center O. The arc AB is 10 centimeters. The radius OA is 15. Find the exact size of angle AOB in radians. So L equals to R theta. Arc length is 10. Radius is 15. So obviously theta equals 10 on 15 radians, which is 2 on 3. All good. 2 on 3 radians. So be careful. It's not, how can I say? I just want to get something clear. If theta was, let's call it 2 pi on 3. What value is pi? 180 degrees. But what if the radius was 2 pi on 3? What's pi? Yes. So it's very important that you understand the context of pi. And in this case, it doesn't matter because there's no pi. But I'm just trying to, because that would be the biggest mistake I probably see. Because to you, I know Novak, being so black and white, you look at it at 2 pi on 3, 2 pi on 3, they're the same. So you've never bothered to realize there's a difference between the two. And I want to highlight that. Angle. If your angle is 2 pi on 3, your pi that you're standing for is 180 degrees. But if I just said the radius was 2 pi on 3, pi is not 180 degrees because it's radius now. So pi can be in anywhere. You just got to know if pi is a degree, then pi is 180. If pi is length, distance, money, time, because you can measure everything in pi, then that should be 3.14. Cool? All right, like I said, it's not going to impact us in this question. I just thought now that I remember to say that. Double I, find the exact area. Area equals half r squared, 15 squared times theta. And it says find the exact area. So whatever that gives you in your calculator. Oh, thanks. 15 squared times 2 on 3 divided by 2, 75 centimeters squared. You won't lose a mark for centimeters squared, but it just makes you look better if you can write it. Any questions? Nice and easy. Let's try another one. Okay, I don't think technically you need to memorize this anymore. It's not in the syllabus because now they make you prove it, but why not know it? If you need to find the area of a segment, this bit here, right? A segment, you know that it's going to be your sector minus your triangle. In other words, it's going to be like this. Your sector minus your half AB sine C, your triangle. And then what we've realized is obviously as you simplify it, you get this. So for those students, I mean for you guys now that you're revising, why not memorize an extra formula? That will be useful. And it's not that hard to memorize because your sector is already this. So all you got to remember is half r squared bracket theta minus sine theta. If you never used it, it's okay. Like I said, you can just derive it from here. Area of a sector minus area of a triangle, which makes a lot of sense, obviously, to get that bit. All good? That's for a segment, which looks like that. All right. Nice and simple. All right, let's do this one. Example 9. The area of the sector OAB, the area of the sector, is 135 pi on 8. Given the radius is 9, find the acute... See, hold on, wait. Let me just make one thing clear before I continue. This pi is what? Why?
Because it's meters.
Yeah, it's centimeters squared, it's area. Your pi is 3.14. It's area. Just so we get that clear. Because I know you guys are looking at pi sometimes and you're thinking 180, 180, 180, but... Okay. Anyways, continue. Find the acute angle. When I find angle, what would my pi be if there is still a pi? 180, if there is still a pi. Leaving your answer in exact form. All right, here we go. I. You know the area equals half r squared theta. Area is 135. Easy stuff. Half radius squared times theta. All right, any questions before I continue? 9 squared divided by 2. So obviously you're going to times it by 2. 270 pi on 8 equals 81 theta. Divide by 81. 270 divided by 8 divided by 81 becomes 5 on 12. So everybody check that. Make sure you get the same answer as me. I got 5 pi on 12. Like I said, if it's in radians, then that's fine. But what's your pi equal to? Just so we all know if we're going to plug this in. Technically 180, so therefore that angle is 75 degrees. Make sense? Hence or otherwise find the shaded area. Anyone want to take a guess at the formula again? Half.
1/2 half squared.
Open bracket.
Theta minus.
Yeah, right. The sector minus the triangle. And there's your half AB sine C. So it's very easy. Half. Here we go. This is the important bit. Half r squared 81 theta 75. No. Minus sine 75. No. It can't be 75 because it's not attached to a trig. So it can't be in degrees. Theta must be in radians. Theta is 5 pi on 12. What's pi? 3.14. Minus sine 75 degrees. If you leave it in degrees, if not, you guys can change sine 75 to 5 pi on 12 as radians. The calculator needs to be in radians. So I'm trying to show you where you will go wrong. Like I can almost guarantee you guys will make a mistake if you're not aware of it. 81 times Oh, it says, hence are those fine, it doesn't say exact. So here we go, 5 times pi on 12 minus sine 75. Answer is 13.9 centimeters squared. So you can't plug in 75 degrees for theta. Just doesn't make sense. Okay? But theta can be 75 degrees, only for your trig. Because when you're signing degrees, that gets you back into radians. Unless you're doing sine of radians, that leaves it in radians anyways. But your calculator needs to be in radian mode. Okay, anyone not able to get that? I just want to make sure on your calculator so you know what you're doing. In either form, degree form, let's just write, this is degree form or rad form.
So for like arc length,
So for like arc length, right? Yep.
if my theta is in radians, I have to use the other formula.
If my theta is in radians.
Isn't in radians.
Isn't in
The
radians.
other formula with angle.
Right. That's what you're saying. You could. So what Novak's asking is like if theta isn't in radians, do I have to use this formula? Well, the simple answer would be definitely, because, wait, why not? It's not definitely, it's why not, because this is already in degrees. Then if you're saying theta isn't in radians, which means theta is in degrees, you might as well have used this one, which is in degrees.
Yeah.
But if you don't want to memorize an extra formula, no. If theta isn't in radians, which means if theta is 30 degrees, you make it in radians. So how do I convert 30 degrees to radians?
Times
Pi on 6, so times by pi on 180, or divide by 180 and put a pi, then you can plug that in, r times pi on 6. So it's not r times 30 degrees. Yes, that's very important that you understand that. It's not r times 30 degrees, because theta must be in radians. So good question. You could use this, of course. I mean, there it is, 2 pi r times 30 on 360. And then 30 on 360 is 1 on 6. No, 1 on 12. And then 2 on 12 gives you 1 on 6. So you'll get the same answer. R pi on 6. So it's meant to be exactly the same. Obviously, this one's easier for degrees. This one's easier for radians. Whatever. If you understand, personally, I don't really teach radians. I think when we did this, I also said the same thing. I'm like, why you guys want to learn an extra formula for nothing? But I feel like what I'm getting from most of you have already memorized it because of school. Then you now need to know the difference between the two, if you've learned it. All right. No more questions?
No.
All right, let's go. Example 10. Two circles, each of radius 10, have their centers 16 centimeters apart. Calculate the area common to both circles. Okay, hold on. Centers 16 centimeters apart. So the radius of this is 10. The radius of the next one is 10, but the centers are only 16 centimeters apart. That means it's overlapping. Okay. Calculate the area common to both circles. So calculate this area. Okay. Hmm. Okay. Let's see what I see. I see, firstly, I don't see a triangle or anything like that, so I'm going to create that. There it is. Once I've got that, I'm looking at it a little bit more. I think so. I think I got it. I can work out this plus this. Yep, got it. That was a tricky one. I'm not sure if there's many of you that would have been able to get that, including extension kids, because they probably wouldn't have drawn the red line straight away. But I think what I just said is, well, we know it's a circle and sectors and segments is what you've done. So if you don't draw your triangles, you're not going to get very far. You guys can probably see the way I'm going to do it, hopefully, is like this. I'm going to find this segment, this segment, and I'm going to find this segment of this triangle. Add them up, and I'm done. So that sounds easy, but let's see if we've got enough information for it. So segment half r squared theta minus sine theta. So what do we've got? We've got half, we've got the radius being 10. We don't have theta. We don't have theta. But what do we have? We've got from here to here is 16. How does that help? How does that help? It doesn't, does it? But I think I can see it now. Okay, so this is 10. Wait, let me just make sure. Yeah, no, it cuts halfway. So that's 10. That plus that, that's 8. Smart. Okay, so how am I going to show this to you guys? So that, yeah, that bit's 10. I think we agree with that as radius. And then what do we know about this length, this whole length now? Now that you see the way I've drawn it, you know that this whole length is 16. So that means halfway would be 8. Once I've got that, it should be okay. So that's theta, adjacent hypotenuse, cos theta equals adjacent over hypotenuse, theta equals inverse cos 8 on 10, 36.86 degrees. That's theta up here, times it by 2, times 2. We'll get the whole angle that we need. Yes, maybe I shouldn't have chosen theta. Let's make it half of theta. So then that way we can all just see times it by 2 is actually my theta, which is the whole thing. The whole thing, yeah. Theta would be times 2, 73.73 or 74. So this is 73.74 degrees, which is not allowed. Minus sine 73.74 degrees. So the answer is half times 10 squared, 73.74 divided by 180, put a pi. Minus, this is allowed. Okay. Let's finish it off. Sine answer 0.96. It's very nice. 24 over 25. Okay, 73.74 times pi on 180. Take away answer times 100 divided by 2 is 16.35. But I did say that it's going to be the black, let's say, plus this red area. So we're going to times that answer by, yeah, 2 areas times 2 equals times 2, around this, around 32.7 or 33 centimeters squared or whatever it was, meters squared, doesn't matter, centimeters squared. Yeah, that was a hard one. That's it. Hard because obviously we gave you nothing. You have to pretty much work it all out. In your exams, they're not as bad. There's obviously an I, double I, triple I. So I would usually be find theta, or they'll give you the diagram and then they'll say, yeah, find this angle. Double I would be, once you find this angle, maybe find one part of the triangle, and then triple I would be get the whole thing out. Something like that. They usually work, they're usually a little bit more lenient than this. Okay. Any more questions on this? Let me see if there's any more. Nope, that's it. Yeah, that's pretty much the hardest one. Okay. That's that done. I'll send you, if you guys want these booklets, you can. I'll send them to you. Is there any nice ones in here? It's integral. Nah, they're pretty straightforward. Okay, let's do some proofs. Six point 6.5. Let's see. All right, before I start with the proofs, you need to know your formulas. Am I going to assume you guys know your formulas by now? Most. Okay. So let's write the ones you need to know. Sec, 1 on cos. Cosec, 1 on sine. Cot, 1 on tan. Tan, sine on cos, which means cot is cos on sine. And then you have sine squared plus cos squared equals 1. Any more? Nah, we don't do it that way. But if you want to, you can memorize the tan relationships. Sec squared minus tan squared equals 1, but nah, I usually just use this guy. From that, you also need to know the more important ones. Sine squared equals 1 minus cos squared, and obviously cos squared equals 1 minus sine squared. There's only, maybe, I'll add an extra 2. These are special, so it's not all the time, but you should know them, I guess. Sine 90 minus theta is cos theta, and vice versa. They're called complementary. The reason why these are called complementary is obviously because this is called cosine. Cosine is complementary of sine, just like cosec would be complementary to sec. cotangent, cot, is co-complementary to tan. So instead of memorizing 1,000 of them, you just need to know the word co means they're all going to be complementary, so that the angles add up to 90 degrees. That means these two are the same. So that's a good one to know. And then you've got your all stations to central, theta, 180 minus theta, 180 plus, 360 minus. And obviously if you are signing something that is in here, so if you're signing 180 take away theta, it's still sine theta. If you're signing something here, it's negative sine theta. If you're signing 360 take away theta, it's negative. If you're cosing this, it's positive. If you're cosing here, it's negative. Cosing here, it's negative, and we get the idea, right? All right. We need these formulas more. Let's start and see some of these questions. Simplify. Yeah, I guess we could do that. Let's try to find the harder ones. Maybe these ones. Prove. Let's see. We'll take them all. And we'll just choose random ones. All right. What do we have? Let's start with, I'll circle the ones I think you guys should do. B, C, D, yeah, F, maybe H. We'll do, I guess we'll do 15. Yeah, I'm not really doing anything. 17. Looks long, so why not? 20. And I guess just as a last one, we'll do that. All right, that should be enough. That's a lot. All right, let's start with B. Simplify. Question 14B. Simplify. I'm just going to make them thetas. They're just annoying for different letters. All right, go. What's your first instinct? Common denominator. If you're not used to that by now, start getting used to that. When you see two fractions, always common denominator. 1 plus sign, right? 1 minus sign. Sine and sine cancels out. 1 plus 1 is 2. 1 minus sine squared is cos squared. You agree with that, Giovanni? 1 minus sine squared is cos squared. And then, if you want to make it one extra step, that becomes 2 sec squared. Because you know sec is 1 on cos. If sec is 1 on cos, therefore sec squared would be 1 on cos squared. You understand the logic of that? So sec is 1 on cos. Squared, squared. Cubed, cubed. And so on. That's what I meant by you've got to really know your formulas. They've got to be 100%. There it is. Anyone have any questions? C. Sine 1 plus cos plus 1 on cos. No, sorry, plus 1 plus cos. Wait, what? Plus 1 plus cos on sine, right? Yes. Okay, what do we do? Common denominator again. What's missing? Missing a sign. So sine times sine is sine squared. This times this is 1 plus cos theta all squared. Sine squared plus 1 plus 2 cos theta plus cos Squared theta, do not ever expand your denominator. Same thing as calculus, you don't expand your denominator. If it's already factorized, don't touch it. Because you rather cancel than expand and forget cancelling. Sine squared plus cos squared, 1. 1 plus 1, 2 plus 2, cos theta, on. Factorize. Cancel, cancel, you're left with 2 on sine, which equals 2 cosec this time, 2 cosec theta. Any questions? One minus sine, 1 plus cos. Yep. What letter was that? D? D. 1 minus sine, 1 plus cos, times 1 plus sine, 1 minus cos. What do you do with a question like that? Just straight multiply. 1 minus sine times 1 plus sine, difference of 2 squares. 1 plus cos, 1 minus cos, again, difference of 2 squares. 1 minus sine squared, 1 minus cos squared, sine squared. Cos on sine, cot squared. Because cos over sine is cot. Cos squared on sine squared is cot squared. But do you want to see what I meant by it's kind of endless? So there's no way you can just wake up and think you're going to be able to get this out. You have to just keep practicing and know your formulas flawlessly. Okay. Let's do h. 1 minus sine theta cos pi on 2 minus theta. H. 1 minus sine theta cos pi on 2 minus theta. What's pi on 2? 90 degrees. So what did we just say about cos 90 minus theta? It's complementary with sine. So equals to sine. So the answer is sine theta times sine theta, sine squared, which equals, you guys used to that by now? 1 minus sine squared is cos squared. Questions there? I'm going a little bit faster because I feel like we're getting close to your prelim, so you need to be fast. But any questions? No? Okay. Number 15, 1 minus tan, 1 plus tan. Okay, let's do it. Question 15. 1 minus tan theta squared plus 1 plus tan theta squared equals 2 sec squared theta, is that what he said? Yep. Okay, it's a proof question now, so at least you know the answer. You start with your left hand side, what do? Expand. Good luck, I'll leave that with you guys now that the answer's in front of you. Okay, let me see. 1 minus 2 tan theta plus tan squared plus 1 plus 2 tan plus tan squared. 2 gone. 1 plus 1 is 2 plus 2 tan squared. Now, if you have memorized your, your relationship between sec and tan, that would have been great because you're only one line away. If you haven't memorized, not to fear, let's do a little bit the longer way. Here we go. 2 plus 2, tan is obviously sine squared on cos squared, multiplied by cos squared, so common denominator. Factorize your 2 out. Cos squared plus sine squared is 1, so the answer is 2 on cos squared, which is 2 sec squared theta. If you knew the formula at this stage, you would have done this. 1 plus tan is sec squared, so there it is. 1 plus tan is not sec. 1 plus tan squared theta is sec squared theta. Should get that clear. So you can't say 1 plus tan cubed is sec cubed. Doesn't work like that. Okay, any questions there? Put that in a bubble. No? All right. Let's try the next 4. Again, maybe I'll let you guys try it on your own. Just those 4. It's good to get it out because there's no point of watching me do it. You got to get used to it. If you can't prove LHS equals right-hand side, RHS, always start from the right-hand side and then try to get the left-hand side. And if that doesn't work, then start with your left-hand side, get to something, start with your right-hand side, hopefully get to the same thing, and then you can say they're the same. So I'll leave that with you guys for a few minutes. You guys got 17 out? One yes. No. Sine squared alpha cos squared beta minus cos squared alpha sine squared beta. Sine squared alpha cos squared beta. Let me see how you did it there, right? What did you try?
Change it to 1 minus sine squared theta.
So let's do it. 17. Remember, don't look into it too much. It'll confuse you because you're looking at nothing if you look into it. Left hand side, just start. The fact that it says sine squared alpha, we're going to change cos squared beta to 1 minus sine squared beta. So left hand side is sine squared alpha, and then instead of cos squared, you change it to 1 minus cos squared, 1 minus sine squared beta. Right? Because you want it in terms of sine and sine. Minus cos. Cos is, again, 1 minus sine squared alpha sine squared beta. And what you're hoping for is once you expand this, something will cancel out. And it does. Sine squared beta plus, see? Like I said at the beginning, if you guys want a single method to be able to do these questions, there isn't. You just got to know your formulas and just do it. Just do it. It's endless. That word was really good. It is endless. You can't just do one question, like maybe in calculus. Once you know how to differentiate, you can pretty much do it for all the different questions. You can't do that for here. Try 19 now. Try 19. If you can't do 19, try 20, try 23. $19. All right, let's see what I would do. Sine squared theta tan theta. Cos squared times cot theta plus 2 sine cos equals tan plus cot. All right. Anyone got it out? What would I be thinking? I guess I know tan and cot are sines and causes, right? So I'm obviously going to prove, in other words, sine theta on cos theta plus cos theta on sine theta. If I can get to somewhere there, we should be good. Or something along those lines. All right, let's see. Start with this one. Oh, That's going to be cubed. Let's see. Who knows? Left-hand side. Like I said, it's endless. So we start. If it doesn't work out, try something else. I'm going to go for tan is sine over cos. So sine squared theta times sine over cos plus cos squared theta times cos over sine plus 2 sine theta cos theta. Any questions at that stage? Anyone? That makes sense what I've done? I literally converted everything to sines and causes. Then sine times sine is sine cubed on cos plus cos cubed on sine plus 2 sine theta cos theta. At this stage, I know I'm going to make a common denominator. That's just how we do them, right? So equals common denominator, so that becomes sine to the power of 4 plus cos to the power of 4 plus 2 sine squared cos squared on cos theta sine theta. Still with me? Now you really got to know what to do with this next step. So it's not something you can just fudge. You actually got to see something. Anyone see it?
You factorize the
Yes, can you be a bit more specific?
sine squared theta and the cos squared theta out?
No.
Sine squared only right now?
Not really. You're not going to take something out. There's something very special about this. Maybe the clue would be this 2.
Okay.
Think of where you've expanded something that had 3 terms, had a 2. Think, go back. Think. Use those brain cells. Expand something, has a 2. Expand something, has a 2.
Even that sine 4 theta times 4 theta to the power of 4.
No. Thought you had it.
That's why I got stuck.
1, 2, 3. 3 things. When you expand. Say that again?
I'm going to say quadratic. I'm going to just take...
It is a quadratic, so I'm going to give you that. But there's a word that you guys are missing.
Trinomial.
Say that again?
Trinomial.
Trinomial, no, that's still a quadratic. Specifically, has a 2. Specifically. Something, when you expand.
Square.
Say it again?
I said perfect square.
That's the one. It's a perfect square. Sine squared theta plus cos squared theta squared. What happened? Sine to the 4. Cos to the 4, 2 times the inside. The fact that you had 3 terms was a tick. You guys narrowed it down to a quadratic or a trinomial factorization. What you will miss, and what the clue is, or you guys that just did binomial or whatever, is the 2. The fact that the 2's there tells you that it's going to be a perfect square. All right, then it's pretty easy. 1 on cos sine. So I'm going to pause there. I'm going to do my right-hand side. My right-hand side was sine on cos plus cos on sine. Sine on cos plus cos on sine. Common denominator, I think we can all see it. Sine squared plus cos squared equal over cos sine equals 1 on cos, and you're done. You could have moved from this and eventually got to the to the right hand side, but why would you? I would just do it like this. Done. Finished. Proven. So the hardest step, well, you have to start. I hope you guys are learning to just start. If you're not starting, it's really, really poor because you can't do it in your with your eyes. It's not going to work out. You got to do it with your hands. You got to write some stuff down. You'll be surprised. Just trust yourself. Common denominators, and then this step. Yeah, you've either seen it before, you know what to do. You haven't seen it before, you wouldn't know what to do. You wouldn't think to do it. Sorry, let's say that. But now that you guys have seen it, you've got to be ready for that. So if you ever get stuck there, if you see three terms, factorize, trinomials, specifically with the two, perfect square. All right, and then yeah. So yeah, I guess with trinomials it would have worked, but like again, you just want to know that it's a perfect square. All right, all good. Let's try 20. Copy that down. Last two. Again, Giovanni, see? Endless. You can't just wake up and say, I'm good at this. You have to just do, you know what I did after I did all this? Tomorrow morning I'll wake up and do it all again. Because I know I'm not going to get 100. Like I might miss that perfect square again tomorrow morning. And that's it. That's the only way you'll get good at proofs. Okay. Again, look at the right hand side. It says sines and causes. So I think you guys know what I would do with my tan and cot. Good luck. I'll leave that with you for a second to try. Paper. All right, left hand side equals, where do we get it up? Sine theta, 1 plus sine cos plus cos, 1 plus cos and sine equals sine theta cos theta plus sine theta on cos theta plus cos theta, common denominators. You can at least take that out. You can take that away from you with this, like common denominators is going to be a fact that you'll need to do every time. Then I think at this stage, I would first expand the numerator. So you get sine cos plus sine squared plus sine cos plus cos squared over, nope, down, over cos over sine. At this stage, again, you can tell from the right-hand side, it's made a common denominator again. So again, common denominator, I get sine squared cos theta plus sine cubed, right? This times this. This times this gives you sine theta cos squared plus cos cubed on sine theta cos theta. Now you're hoping for the top to become sine plus cos theta. All right, let's do it. So, I'm going to get rid of a few terms, right? So I'm thinking let's change, I'm going to say let's change this guy to 1 minus cos and change this guy and fingers crossed. So the only thing you know at this stage really is sine squared is 1 minus cos squared. That's it. So that's what I'm going to do. Times cos. Don't change cube because you can't do anything with it. Change cos squared again to 1 minus sine squared. And if we've done it right, just observe the line. Look at it. Minus cos cubed plus cos cubed. Minus sine cubed plus sine cubed. So literally all you'll have left is cos theta plus sine theta, exactly as you needed. Everyone see that? So I'm not going to expand everything because why would you waste your time? You just write cos theta plus sine theta on. Otherwise, yeah, everything else cancels out. Like that would technically cancel out with that, and that would cancel out with, sorry, the other way, that cancels out with that. The sine will cancel out with the sine cubed when you expand it. And all you should have left is cos theta times 1, sine theta times 1 equals right hand side. All right. All good? Last one. 23. Let me know, you guys, if I'm going too fast. 23.
Hey, Sin, just for the last question, on the third last line where it has sine squared, why is it sine squared? Aren't we just multiplying?
Sine times sine theta cos theta becomes sine squared. Sine times sine squared becomes sine cubed. Plus these two multiplied by cos become, does that make sense?
Yeah, sorry, I skipped just something. Okay, that makes
Plus
sense.
multiply.
Yeah.
If you guys are ready, start question 23, which is down here. A clue would only be obviously changing, other than changing everything to sines and causes. Don't try to use your fraction sign, and try to use a division sign, and maybe just work with this first. Just work with that second, then subtract your simplified answer. Otherwise, if you're going to do it as one big question, if you're not strong with your algebra, you will stuff up. So start with that one by itself, start that one by itself, then subtract your simplified answers, and then try to go for the final one. That's my clue for now. I'll still leave it with you guys a little bit longer. Okay, I'm going to start with the left hand side and just our component. So 1 plus cot on cosec equals 1 plus cos on sine divided by 1 on sine. Common denominator, you get sine theta plus cos theta on sine theta times sine on 1. And that's why I taught you guys to not use your fractions is that if there's fractions and fractions, because then that simplifies to just a simple sine theta plus cos theta. Next one, sec theta on tan plus cot equals to 1 on cos for sec divided by tan plus cot. 1 on cos, divide, common denominator, sine squared plus cos squared on 1 on cos, multiply and flip. So of course we know that's over 1. Sine squared plus cos squared is 1. Cos and cos cancels out. And you're left with sine theta. See how neat that becomes? And then all you're going to do is do the 1 plus cot minus the sec. So sine theta plus cos theta minus sine theta obviously equals to cos theta. Simple when you see it like that. That's the way any student should really do it. You shouldn't really do it as a whole thing. If you did, you're really on overkill. Because that's, cot is a fraction. over a fraction, mine is a fraction over fractions, fractions and fractions upon fractions. I mean, I'm telling you as like an expert in this, I would not do it. I wouldn't do it. There's no reason why you guys think you should be doing it. I will split it up, nice and simple, everything looks a lot cleaner, and you're done. Question?
Just for the first one.
First line. Cos and sine.
What do you do to change it?
What did I do to change what? 1 plus cos is cos and
No,
sine.
after.
Divide?
The one that's
Oh, common denominator, right? Sine times 1 is sine plus cos over sine times flip.
Yeah. I don't.
Always. What did I say to you? The one thing you want to take out of this is common denominators. If you're not going to do your common denominators, you're not going to get anywhere for trig. Everything's got to be common denominators. And again here, look, sine on cos plus cos on sine, common denominator. These two multiply, then you cross. Looks like that, flip, looks like that. Any questions? Okay. No, nothing? All right, that's proofs done. What's our next one? We said functions, I think. Yep, so functions, time for functions. 120 functions. I don't know how fast we're going to be able to do it, but we'll try. Maybe from here. Function. Was Sandra in yet? No, he's forgotten, hasn't he? Yep. Oh, he missed out. Functions. So, let's do these example questions. I'm going to circle the ones I think you guys will get wrong. So, 1A, B, 4, E, let's do them. Those 4, try them out. Did I pop up?
Yeah.
Do you have USB-C? What is it? USB-C, that's what it's called. Unless that's the one. Charge it anyways, and get it out of this charge. Make sure. It just is. If you want to move forward, you can use that, I guess, up to you. All right. This one becomes x cubed on y cubed. Divide x squared on y cubed, because y to the negative 3 is y to the 3 in the denominator. And then x cubed on y cubed. You don't have to do that, even if you got the right answer, using your own method, whatever it was, it's fine. The answer should be x. You guys able to get it out? If you weren't, you know then that means I was right. We're saying that it was harder, or you would get it wrong. And that's not good. You don't want me to be right. Which means if I'm right, your teachers know that that's your weakness as well. Therefore, they're going to put that in your exam. It's very simple. Equals. This one, very simple. You just add the powers, really. 1/3 plus 5 on 3 should be 2. So that just gives you x squared. Any questions there? Number 4. That should be, coming from calculus. So you should know you can't have surds in the denominator for calculus, so you would have already perfected this, hopefully. The answer should be x plus a to the power of negative half. You can't have x in the denominator for your calculus, and surds are powers of halves. So -1, and then because the surd, 1 on 2. All good? Last one, common denominator here. Your common denominator is obviously 3x. If it's the same, you choose the highest one, which is just going to be x, so 3x, and then times it by 3. What's missing from here and here? Nothing, so just leave it as 2x plus 1. If you don't use your brackets, you lose a mark. 3x minus 2x is x. 3 minus 1 is 2. That's the answer. Anyone happy with that? Any questions? Okay, let's do, I guess we'll do 8. Let's do it. Average cost per unit for the production of X units is as average cost equals total cost on X. So a company producing a certain product finds that the average cost of production is given by 6,000 on X plus 65 plus 0.1X, where X is the number of units. Write this expression as a single fraction. So write 6,000 on X plus 65 plus 0.1x as a single fraction. What's the first thing you would have to do if you want to change it to a single fraction? What's really annoying? Or what's hiding? There's something in there that's hiding. Sorry? Yeah, not over 1, over 10. 0.1. So 0.1x, you don't want to use 0.1 because 0.1 is a fraction. So it's 6,000 on x plus 65 plus x on 10. Now you can have it as a single fraction. Equals common denominator 60,000 plus 650x plus x squared. Does that make sense? So the trick to that was a 0.1. Probably a lot of students would have missed that. Find an expression for the total cost for production of X units by the company. Find the total cost for the production of X units by the company. Well, if the average cost is total cost on X, That means total cost is average cost times x. So total cost is equal to average cost times x. Correct? Very easy. Just times this by x. What's the answer? X's cancel out. 60,000 plus 650 x plus x squared on 10. I know you guys are still struggling with the words. You've got to understand how simple the math is meant to be. You're meant to kind of move away from the words. Don't let that scare you. So yeah, TC, total cost, is equal to average cost on X, which means just times by the X. Any questions? All right. Yeah, I guess question 2 is good. So try question 2 real quick. Maybe do A, D, and G, and then we'll do 5. So try domain and range for this one, and then try question 3, odds and evens, and then try question 5. Okay, domain of the original, of the top one, square root of x minus 4. You know x can't be 3 because it'll give you a negative number. It can't be 2, gives you a negative. So x must be greater than or equal to 4. If your teachers have taught you to do interval notation, then you'll do it in interval notation. Should look something like this, I guess. X is an element, depends on what you've been taught. There's so many variations. X is an element of the real field where x is 4, inclusive of 4, to infinity. Something like that. But that's just annoying to me. Range. Obviously, you know that the square root will never be negative. So therefore, your range must be of y is greater than or equal to 0. Square root will never be negative, so y must be greater than or equal to 0. Any questions about A? B, it's a parabola, so all real x. Your range, obviously it's shifted up 1, so your range is greater than or equal to 1. Question 3, odds and evens. What's the way we start? We always start with sub in negative x. If it gives you the original, even. If it doesn't, you force out a negative. If it gives you negative of the original, it's odd. Ugh, too many D's. And if it's not, then it's neither. So sub it in, gives you the original, even. Not, force out the negative. Odd, great, not, neither. Let's go. F of x equals 4x. So sub in f of negative x, gives you negative 4x. Is that the original? No. Force out a negative. It is negative of the original. So guess what? It's negative f of x, which is odd. 3a, 3d. F of x equals x cubed plus 3x squared. Sub in negative x, that's just how it always works. Negative cubed is negative. Negative squared is positive. So it'll look like this. That's not the original. We force out a negative. That's still not the original. So therefore, it's not negative f of x, and it's not f of x. Therefore, neither. And then I think the last one was 2 to the x. Any questions about these? Hopefully it's a nice refresher now. Sub in negative x gives you that. Obviously straight away just by looking at it, that's not the original. And even if you take out a negative, you're not going to take out a negative from the power, are you? You're going to take out a negative from the front. So it's going to look something like this. Obviously, this is again negative. All right. And any more? Oh yeah, number 5. A function has a domain and a range. It is also known that the function is even. Draw a possible graph. Okay. So its domain is from -2 to 2. Its range is from 1 to 6. And it is even. Okay. What would you have drawn? Semicircle. Semicircle this way?
Yeah.
Yeah, I guess I can accept that. Like that, something like that?
Yeah.
Or the other way even if you went this way. Anything, as long as it's symmetrical, I guess. I would have done like a parabola kind of thing. So I started somewhere here, -2 and 6. Maybe come down, and then again, there, at 2 and 6. Then it's symmetrical again, isn't it? And my range is from 1 to 6, starts and stops, and it starts at -2 here and it stops at 2 here. No arrowheads, as long as it's symmetrical. I think that's the key thing. Cool, which is like a semicircle. I guess that's probably where you got your idea from. That's fine. You could have done a semicircle, whatever. All right. Any questions? All right. Find the equation of a line. Yeah, maybe C. Oh, 3. I don't think you guys are going to get it right. I guess we'll do one of these ones. 5. All right, start with C. Find the equation of a line that is parallel to this and crosses the x-axis at x equals 3. I'll leave that with you guys. Think about. It's not that hard. Just so you guys don't get all disheartened by everything, don't forget, we're doing all the hardest questions. So like those trig proofs and stuff, we've just done all the hardest ones. In your yearly exams, they don't work like that. You'll get like increasing in difficulty. So it's not just going to be every single one's going to be hard. So just keep that in mind. So I wouldn't say these are technically all going to be examinable because you won't get all the hardest questions in your exam. But if your last one's trig, I'd say, then you could do one of those. That'll be like the last question. Okay, find the equation of the line that is parallel to this. So straight away, I think of y equals mx plus b. So 6y equals negative 2x plus 7 divide 6 divide 6. So m1 equals negative a third. And parallel to it is still negative a third. Crosses the x-axis, which means y equals 0 at x equals 3. So there's your point. Y minus y1 equals m, x minus x1, y equals negative a third, x plus 1. Easy. This one. Anyone got it out? What'd you use? Yeah, as you know it. Good job. Find the range of values of k for which this is always positive. For a function, for a parabola, to always be positive, it means that the discriminant needs to be greater than 0. The logic to it is if it's always positive, so it's always above the x-axis, then it's got no roots. No roots meant discriminant is greater than, sorry. Discriminant is less than 0. It's got no roots. You understand? It's got no roots. And same thing for this way. If it says always negative, the discriminant must still be less than 0. So for it to always be positive or negative, it must have no roots. Does that make sense? Okay, well, if there's a parabola, how many roots does this have? How many roots? You don't know what roots are? Yeah, intercepts. So how many roots does this one have? 2. 2 roots, discriminant greater than 0. Unless you don't know what discriminant is. You've forgotten that? B squared minus 4ac, and the discriminant tells you how many roots you also have. So if it's greater than 0, you've got 2 roots. But can you see how your function is both positive and negative? So you got y values that are positive and you got y values that are negative. You guys see that? Okay, so that's 2 roots. If you had 1 root, it would look like this. 1 root, let's say. Right? Or 1 root. For it to have 1 root, then the discriminant is equal to 0. But is it always positive? Well, right here, is that positive? No. Right there. That's 0. Is 0 a positive number or a negative number? It's neutral. It's neither positive nor negative. So that has 1 root. That's what discriminant equals to 0. So if you want something to always be positive or always to be negative, it's right here. It's got to always be positive and it's got no roots. Or sad like this, and it's not touching the curve and it's not cutting the curve. So it's got no roots. For it to always be positive. How do you know if it's always positive or negative now? Positive and negative is about this number. What's the number in front of x squared? Positive 1. So the fact that this value, let's call it a, because ax squared plus bx plus c, since a is greater than 0, it's positive. It's a happy parabola. If a was less than 0, it'll be a sad parabola. But your discriminant must still be less than 0 for it to always be positive or negative. So let's do that now. Now that we can accept that the discriminant equals b squared minus 4 times a times c, and that has to always be less than 0 for it to be positive or negative, always. All right, 4 minus 4 minus 4 less than negative 4, divide by negative 4, greater than 1, take away 3, negative 2, and then again divide, k is less than 1. As long as your k value is less than 1, this parabola will always be positive. So essentially it will never have a root, as long as k is less than 1. If k equals to 1, it'll probably have 1 root. If k is bigger than 1, it'll have more than 1 root. And you can test it and check it out, but that's the idea. If it's got more than 1 root, that means it's positive and negative. If it's got 1 root, it means it's usually positive, but then there is a point there where, yeah, all right, I'm not going to confuse everyone. You just need to memorize always positive or always negative. Discriminant is less than 0. All right. Number 5. Peter owns a publishing company and sells calendars, for $30 each. The cost of producing these calendars, including a setup cost of $5,000 and additional cost of $5 per calendar. What is his break-even point? How many calendars does he need to sell to cover his cost? Well, okay, that's not too hard. Sell equals, I like to use R, because that's proper business terms. Revenue equals $30 times X. Would you agree with that? Revenue, the amount of money you make is 30 times each calendar. The cost equals 5,000 plus 5X. And how do you work out break even? Revenue must equal to? How do you work out what you need to sell just to cover your cost. Revenue must equal to, no. Revenue must equal to your cost. You guys get that? Like imagine it like this. This is your cost function. This is your revenue function. And obviously to work out where your break even, it's where revenue equals to your cost. That's just in anything. I mean, if you guys were going to open up a cupcake business tomorrow, you're going to say, okay, it's going to cost me $5,000 plus $5 for each cupcake. But I can sell them for $30 a cake. How many do I need to make just so that I can say I'm even? I'm not losing money, I'm not making money. You would say, of course, 30x equals 5,000 plus 5x. Like I said, your revenue must equal to your cost. All right, and then bring it over to one side. Divide by 25. Our number should be 20 or something. 200. So if you can sell 200 cakes, calendars, whatever, you're not making any money, but you're also not losing any money. Make sense? The reason why it's obviously $5,000 because you probably have to print the calendars and stuff. That's why it's a very, very high cost. But if you can sell 200, you made your money back, which isn't too bad if you think about it for a whole year. If you can sell 200 in a year, which you should be able to, if you think of a calendar, it covers your cost of making the calendar. Sorry, makes the cost of making the calendar, which is 5x, but as well as the whole setup cost. Anyways, which is good. Simple math, but again, I don't think you guys would have written it like that. You would have just over confused yourself and wouldn't have looked good. All right, last page. Let's definitely do question 1, because that's a no-brainer. That'll be in your exam. I sent you guys the video from Thursday, so I think we did an exam on Thursday. If you want me to go through a whole exam, just probably go watch the Thursday one, since we did all this today. Sketch, that one's a guaranteed as well. Let's see, anything else? I guess we'll just do one of these, this, whatever it is. Okay.
So now I'm left with that. Can you say the question?
Yep. Sketch the graph f of x equals x minus 1 cubed x plus 2 minus 1 all cubed and multiplied by x plus 2. Identify all important features. Okay, very straightforward. If we know our rules, I think we did this last week, the rules of sketching. If it wasn't your class, it would have been a different class. But I'm sure I've sent the videos. So here we go. What's the highest power of the polynomial? The whole polynomial. 4. So the whole polynomial, the highest power is x to the 4. That tells you where to start. You're going to start at the top, right? Because that's where your even power starts. This guy, x plus 2, what does it tell you to do? Cut through. And the word I usually use for the x minus 1 is squiggly. So nice and easy. If you know that, here we go. So starting at the top, you're going to cut through at -2, you're going to squiggle at 1. So cut through, squiggle. There we go. And the only other thing you need to put in is your y-intercept. When x is 0, you'll get -1 times 2, which is -2. You have to put a y-intercept of -2. And then, yep, looks good. No, no. Okay. Any questions there? If you have forgotten those rules of cutting through square and what to do with squares, bouncy, and how to look for your highest polynomial, again, revise your work, go over it, should come to you in no time. Sketch the graph of question. Well, any questions for question that one? No. 9. F of x. F of x equals 4 on x plus 3. What is that? What kind of graph is that?
One,
A line? No. 4 on x plus 3. Hyperbola. Hyperbola that's been shifted up 3. So it's 4 on x and then plus 3. So a hyperbola shifted up 3. That means your asymptote is no longer at 0, it's at 3. This asymptote hasn't changed, and voila. But you do have an x-intercept now, so when y equals to 0, you can actually work it out. Minus 3 times by x, divide by 3. So that becomes 4 on negative 3. So you do get an x-intercept this time of 4 on negative 3. How do we find g of x, which is 1 plus f of x? Well, now that you have your f of x, 1 plus that just means shift the whole thing up 1 again. So for g of x, it's just your asymptote's not at 3 now, it's at 4 now.
Did we draw on the same?
Oh, you don't have to. There it is, and there it is. Ugh. I usually would not draw on the same if we can avoid that. And then again, you should be able to work out this number here. I think it's going to be negative 1. How do you do that? Well, f of x is, 4 on x plus 3. And then just go and solve for 0. So your x-intercept should be negative 1. Any questions? Next one. Absolute value of 2x take away 3. Absolute value of 2x take away 3. What's our shape? V. When x is 0, you'll get a y value of positive 3. When y is 0, you get an x value of positive 3 on 2. So just go and find your intercepts and then draw a V. Very easy. So x-intercept 3 on 2, y-intercept positive 3. Any questions? Nope. Last one. I think we've done this now maybe 2 or 3 times, this kind of question, and I haven't seen it being very successful. I think on Thursday, 1 or 2 got it out, and I can't say it's been very successful, so let's see. The saying finds that for a certain species of fish, the mass of a fish is directly proportional to the cube of the length of fish. So what's the formula we need? Directly proportional to the cube of the length of fish. The mass is directly. Does anyone remember what letter? There's a specific letter that I need to know. Yeah, I guess. Oh, no. You're thinking of science now. But it's a similar concept, but we don't need that. In science, they forget this. In math, we introduce a letter. No one knows the letter that we use. Because if you know the letter, then that means you know what to do with this question.
Would it be D?
D, no. K. These are the K questions. Some of you I can see here going, oh yes, I remember now, but you can't forget it. So if you see that this word proportionality, you're talking about any constant, and the letters we usually use, the letter we usually use is K. This is the way it works. Mass directly, not inversely. The question we've done before was inverse, so we put in the denominator directly. So mass equals K, that's the proportionality, cube of the length, L cubed. So M equals K times L cubed. You need that. Without that formula, you can't get anywhere. Okay? Direct proportionality. Again, if that's a weakness, if you completely don't know this, just go back to your chapter 1 or chapter 2, whatever this would have been, and just do 2 or 3 questions. It should all come back to you. For this species, if a fish of length 25 has mass 870, what is the length if the mass is 1.3? Okay, here we go. So 25 centimeters, mass is 870. You always have to find your K. So 870 on 25 cubed equals K, which is 870 on 25 cubed. 174 on 3125. Or in other words, 0.05568. Now that you have found K, can you see you have an equation that's relating M and L, and it's no longer proportional to it. It can actually be an expression. So the the fact that it's proportional is trying to say, we know that they're related, we don't know by how much. We don't know if it's 2 or 3 or 4. And then the question just says, what is the length if the mass is 1.3? So we're not done. What is the length if the mass is 1.3? Kilograms, this was in grams. So you've got to change this to 1,300 grams, sub it in. We don't need the G. And solve for L. Divide, so 1,300 divided by that. And then cube root it. Cube root, the answer for the length is 28.6 centimeters. So the math again to this question is pretty straightforward. It's just this first line. If you don't know that, you're going to get really stuck with the question. So let me just see if I can find you a quick another one with there. Yeah, number 3. We'll just get the first line out, just so you guys can get used to this. Fred has made an electrical circuit in which the current varies inversely with the resistance. So it's not directly. So this time it's C equals K on R. It doesn't say cubed, it doesn't say squared, it just says it varies inversely with resistance. And then of course you go and substitute, your resistance is 10, current is 8.6, you'll get your K. Once you've got that, what is the current when resistance is 12? Current is 86 on 12. So you can see without the first formula, you're going to get stuck. Keyword there was inversely. This one was directly. And then cube length. All right, if you've got any questions, please stay back. Otherwise, I will